Okay, we are on our last section of the final review. We're going to look at radicals and quadratic equations. This is problems 25 through 28. So the first thing we want to talk about is simplifying radicals. We're going to assume all variables are non-negative. Don't worry about what that means. Okay, so the first thing we want to do is combine into a single root. To simplify, we're going to take the square root of the number and then divide the exponent by 2. So for example A, when we combine this into a single radical, we're going to multiply the numbers. We get 5 times 20 is 100. We're going to add the exponents, and so we get x to the 3 plus 1 is 4. To simplify the square root, we're going to take the square root of 100, which is 10. We're going to divide the exponent by 2, and we get x squared. For example B, we multiply our numbers. 2 times 32 is 64. We add our exponents and we get x to the 12th. If we take the square root, we get square root of 64 is 8. And the square root of x to the 12th, if we divide by 2, we get x to the 6th. All right, so that takes care of multiplying some radicals. So let's talk about dividing radicals. Same idea. If we combine into a single radical, we're going to divide our numbers. 48 divided by 3 is 16. A to the 7th over a to the 8th, we're going to go ahead and divide by, or we're going to subtract our exponents. We get a to the 6th. And then we take our square root. Square root of 16 is 4. If we divide 6 by 2, we get a cubed. Now please note that we do not continue taking the square root of 4. Once we take the square root, we're done with it. Last one. If we combine into a single radical, we're going to divide our numbers. 72 divided by 2 is 36. If we subtract our exponents, we get 3 minus 1 is 2. All right, we take our square root. Square root of 36 is 6. And the square root of x squared is x. All right, that takes care of our simplifying square roots. All right, the next thing that we're going to look at is solving radical equations. In order to solve a radical equation, remember we want to start by isolating the root. We're going to square both sides and then finish solving. Technically, you should check your solution, but we're going to see that all of these are okay except for one, and we'll talk about that in a minute. Okay, so let's go ahead and look at our examples. Example A, we have the square root of 2x minus 1 equals 6. Our radical, or our root, is already isolated. Everything is underneath the square root. We don't have anything outside. So my first step is going to be square both sides. And if we square both sides, on the left, my root and my square cancel, leaving me with 2x minus 1 equals 6 squared is 36. Okay, we can add 1 to both sides. We're going to finish solving. We get 2x equals 37. And then we can divide by 2. So we get x equals 37 over 2. All right, next one. Example B, we have the square root of x minus 3 plus 5 equals 11. So the first thing we want to do is isolate the radical. We want to get rid of the plus 5 on the outside. I can subtract 5 from both sides, and we get the square root of x minus 3 equals 6. We go ahead and square both sides. On the left, my square root and my square cancel, leaving me with x minus 3. And on the right, we get 6 squared is 36. To finish solving, we're going to go ahead and add 3 to both sides. And we get x equals 39. Okay, let's try a couple more. C, we have the square root of x plus 1 minus 4 equals 3. So if we isolate our root, we're going to add 4 to both sides. We get the square root of x plus 1 equals 7. We square both sides. On the left, my square and my square root cancel. So we get x plus 1 equals 49. Subtract 1 from both sides. And we get x equals 48. All right, last one. First thing we want to do is isolate our radical. So we're going to subtract 2 from both sides. We get the square root of x plus 3 equals -1. I can actually stop at this point because remember that when we take the square root of a positive number, we always get a positive number. You can't take the square root of something and end up with a negative number. And so right here, we can go ahead and stop and say, no solution. Now, if you continue from here, you do need to check your solution, and you will find that it does not work, which means that it is extraneous. So let's see what that looks like. If I square both sides, we get x plus 3 equals 1. I subtract 3 from both sides, and we get x equals -2. So if we check our solution, we get the square root of -2 plus 3 plus 2 equals 1. -2 plus 3 is 1. The square root of 1 is 1. And 1 plus 2 is equal to 3, not 1. So -2 is extraneous. Our answer is no solution. All right, so that takes care of solving radical equations. The next thing we're going to look at is the solving using the quadratic formula. So we want to plug into our quadratic formula. We get x our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So for example A, if we go ahead and plug into our formula, we're going to label A is 6, B equals negative 3, and C equals negative 4. So when we plug in, we get x equals minus negative 3 becomes plus 3, plus or minus negative 3 squared minus 4 times 6 times negative 4. Over 2 times 6. All right, if we go ahead and simplify now, we get x equals 3 plus or minus the square root of 9 plus 96. We're going to multiply negative 4 times 6 times negative 4 all over 12. And for our final answer, we get 3 plus or minus the square root of 105 over 12. 105, we cannot simplify that square root, and so we are done at this stage. Let's try one more. We have 4x squared minus 4x minus 1. First thing we're going to do is label our a, b, and c. We get a equals 4, b equals negative 4, and c equals negative 1. So when we plug into our formula, we get minus negative 4 becomes plus 4, plus or minus the square root of negative 4 squared minus 4 times 4 times negative 1 all over 2 times 4. If we simplify now, we get x equals 4 plus or minus the square root of 16. Negative 4 times negative 1 is also 16. And 2 times 4 is 8. We can add inside the square root. We get the square root of 32. And for this one, we do want to simplify our square root. So 32, what is the largest square that goes into 32? The answer is 16. This breaks down to 16 times 2. And if I take the square root of 16, we get 4 plus or minus square root of 16 is 4. And we leave the 2 inside. Last step, we want to simplify the fraction. All of our outside numbers are divisible by 4. So if we divide them all by 4, we get x equals 4 divided by 4 is 1. Plus or minus 4 divided by 4 is 1. Square root of 2 over 8 divided by 4 is 2. And so those are our final answers. All right, that takes care of our quadratic formula. All right, the last examples we have is graphing quadratic equations. So in order to do this, we want to find the vertex, the y-intercept, and the x-intercepts. So if we go ahead and start with our vertex, recall that our vertex, we're going to use the formula x equals negative b over 2a. If we plug in our numbers, we get b is negative 4, so minus negative 4 becomes positive 4 over 2 times 1, or 2. And we get 4 divided by 2 is 2. So remember that what this means is our x coordinate is 2. We still need to find our y coordinate. So for our y coordinate, we're going to go ahead and plug in 2 to our original equation. We get 2 squared minus 4 times 2 plus 3. 2 squared is 4. 4 times 2 is 8. We bring down our plus 3. And if we finish this off, we get 4 plus 3 is 7. Minus 8 is negative 1. So the y-coordinate for the vertex is negative 1. That means that my vertex is 2, negative 1. Okay, next thing we want to find is our y-intercept. So for our y-intercept, we're going to go ahead and plug in 0 for x. We get 0 squared minus 4 times 0 plus 3. And all of my x terms cancel, leaving me with 3. So my y-intercept, x is 0, y is 3. Okay, the last thing that we have is x-intercepts. So for x-intercepts, we're going to plug in 0 for y. And we want to solve for x. So we're going to go ahead and factor this. We get x and x. Things that multiply to 3 are 3 and 1. We have same signs. Both are negative. All right, if we set each one of these little factors equal to 0 and solve, we get x equals 1. As an x-intercept, this is 1, 0. And we get x equals 3. As an x-intercept, this is 3, 0. All right, so let's go ahead and plot these points. We have our vertex is 2, negative 1. We have our y-intercept is 0, 3. And we have our x-intercepts at 1, 0 and 3, 0. we go ahead and draw our graph through the points. And hopefully it looks a little better than that. Alright, so for our next example, we have y equals x squared plus 2x minus 8. Same thing again, we want to find the vertex. We're going to plug in our b and a into our formula, x equals negative b over 2a. We get minus 2 over 2 times 1, or 2. And if we simplify this down, we get negative 1. So remember, this is our x coordinate. We still need to find our y coordinate. So for my y coordinate, I'm going to plug in my x value, so we get negative 1 squared plus 2 times negative 1 minus 8. If we go ahead and simplify this, we get 1 minus 2 minus 8 equals negative 9. So remember that this is my y-coordinate of the vertex. My vertex in general is going to be negative 1, negative 9. All right, let's find our y-intercept. If we plug in 0 for x, we get 0 squared plus 2 times 0 minus 8. My x terms cancel, and I am left with negative 8. So my y-intercept, x is 0, y is negative 8. And finally, we want to find our x-intercepts. So for x-intercepts, we're going to plug in 0 for y, and we solve for x. So if we factor this, we get x and x. Things that multiply to 8 and combine to 2 are 4 and 2. We have different signs. My larger number will be positive, so we get x plus 4 and x minus 2. If we set each one of these factors equal to 0 and solve, we get, subtract 4 on the first one, x equals negative 4. Add 2 on the second one, we get x equals 2. So my x-intercepts are going to be negative 4, comma, 0, and 2, comma, 0. Okay, so if we go ahead and plot these points now, we have our vertex at negative 1, negative 9, our y-intercept at 0, negative 8, and our x-intercepts at negative 4, 0, and 2, 0. So if we go ahead and connect the dots, we draw our parabola. It should look something like that, hopefully better. All right, so that takes care of the final review. Good luck on your final exam. Have a good summer vacation, or vacation in general, and hopefully we will see you again next semester.